So what we're going to be doing today, I need to give you a couple reminders, and then I'm going to talk to you about the second lab that we're going to be doing, which is kind of an extension of what you did before with the Moving Man lab, but really focusing in on the graphing and analyzing the graphs and thinking about mathematical models more deeply than on the initial exercise. So the two reminders, though, before we jump into that. First, if you are planning to turn in corrections for the Unit 2 test to earn the curved grade, those need to be done by tomorrow night at 11:59 p.m. Pacific time. So make sure you're getting those corrections completed and submitted so that I can change your score to the curved score. And then if you are planning to do a retake, I had a few people do it last week before the long weekend. And if you still would like to do that, you can do that today at 3:30 or tomorrow, Friday at 3:30. Those are the two options. It's a 60-minute timed test. Remember, if you do the retake, then your score will be the retake grade. Whether it's better or lower, your grade will still be that retake grade. So don't just come into it cold if you haven't been preparing and just hope you do better, because if you don't, then your lower score would be your final score. So make sure if you are going to do the retake that you are preparing and that you're ready for that. The retake is optional, and technically the corrections are optional, but you don't earn the curve if you don't do the retake. So, or sorry, don't do the corrections. So, Alex, do you have a question?
Yeah, this is a pretty stupid question, but are we gonna have a curve on the retake?
On the retakes, the curve is automatic. You don't have to do corrections to earn it, just for expediency and also to reward you for taking the time to prepare twice. So if you take the retake, you automatically get the curve. And it's approximately the same curve. In fact, I think on this one, it turned out to be exactly the same curve. Sometimes if the questions don't end up being the same number, or if there's more FRQs and fewer multiple choice, because it's not always easy to make them perfectly matching. Sometimes the curve ends up slightly different, but this time I'm pretty sure, if I remember correctly, it was the exact same number of each kind of questions and relative same difficulty for the questions. So the curve ended up being the same. All right, so just those two reminders. If you want to get those test corrections, then make sure you're getting them turned in by tomorrow night to earn the curve on Unit 2 test. And if you want to retake, it's at 3:30 today or 3:30 tomorrow. 60-minute time test, you earn the retake score if you do it. Then an announcement for today. I mentioned this before the long weekend, that the predicted date for our test on the unit that we're currently on, Unit 3, would be not today, but next Thursday. So it was basically 2 weeks from the last time we met, since it's been a week ago already. But that is still the planned date. That I feel like today we should have time to get a good portion of the lab done in class. And then on Monday next week, you'll have some class time. I'll take some class time, maybe 30 minutes, to review with you and then answer some questions, make sure you know exactly how to prepare for that Unit 3 test. And then the rest of the time will just be for you to either review on your own or continue working with your group on the lab. And this will be the first time we're attempting to do a lab in more of a group setting while we're still remote. So this will be a little bit of an experiment to see if we can manage this well. But that's the plan. So today, doing the lab, Monday, reviewing and finishing the lab, and then on Thursday next week, actually having the Unit 3 test is the timeline. And you can see the lab is due Monday night, and you can see the test is on the calendar. I think it shows. Can you see the test on the calendar yet? I think I did publish it this time. Can you see it? I guess I can check myself too, but if any of you are on Access, you can let me know. Any questions about timelines or schedule or anything like that before we go into today's lab? All right. So for the lab, first let me just review a couple of things that you'll need to know very well with some slides. Nothing new here, but I want to take maybe 5 to 10 minutes to make sure that all of this is really clear in your brains, that you can get some last minute questions asked. Otherwise, this lab could be pretty challenging if some of these things aren't clear to you yet. So let me just take a few minutes to be sure that you understand these elements of graphing. You may want to either take some snapshots or jot down some notes. so that you can make sure that you remember all of this as you're going through the lab. The lab is not difficult in terms of collecting the data. You're just going to go back to that same moving man FET, and you're going to, which you can access on Axis. And then you're going to be making some graphs and then making some models, but editing those graphs a little bit more than you did the first time around. Instead of just sketching their shapes, you're going to be actually graphing them more precisely. All right, so first let's review position time graphs. That's where you're going to start on the lab today. So you'll collect some position time data using the moving man simulation. And remember that an object's position at any point in time can be graphed if we put position, and you'll want to make sure your graphs match this pattern. If we say position versus time, position is on the Y, time is on the X, okay? And these graphs will show you the position, but you can also use it to figure out the velocity, because the slope of a position time graph tells you the velocity. You're going to make sure that your position is the dependent variable on the y-axis and time is your independent on the x-axis. And when you write your models, you're always going to want to make sure that it's in the linear slope intercept form, but you don't ever just write this generic form. You have to substitute, like we've done since unit 1, for y. Your y is the x, and your slope is the velocity, your x variable is time, and your y-intercept would be the initial position. All right, so your final position would be the y value based on the inputs you have for these. You could simplify this a bit, because if you take final position minus initial position, that is delta x. So delta x would be VT. Now keep in mind that you have to get it into slope intercept form before, or sorry, into linear graph before you can put it into this slope intercept form. And while that can be represented either way, this first one, xf equals vt plus x0, that's the one I want you to use in your lab. Okay, so that's what we're looking for. Now, in the moving man, on this scenario, I want you to make sure that the moving man has an acceleration. Okay, the lab won't work unless you make sure the moving man has an acceleration. So it can be whatever acceleration you want. It can be very small. It can be very large. Well, it can't be too large, because you need to be able to get enough data points. So you need to try to follow the 8x10 rule. Remember, that means 8 data points, where your smallest data point is 1/10 of your largest, or you could say your largest is 10 times your smallest. So if you make the acceleration too high for the moving man, then it may move along so fast it's hard to get enough data points. So probably something slow to medium, or low to middle level acceleration, so you can get enough data points to get that whole 8x10 satisfied in your collection. But there must be an acceleration. All right. Any questions about position time graphs? Since I'm asking you to put an acceleration, what is the generic or general shape of your position time graph going to be? So Ian go like this. So it's going to look like part of a parabola. It's going to be curving in nature. So you will have to linearize it. And the instructions tell you and give you a couple reminders about doing the linearization. And so since it's going to be quadratic and it's going to be curving upward like part of a parabola, you're going to need to figure out what should you do to the x-axis in order to linearize it. And then you're going to modify the data and then make a linearized graph, and then come up with your model. So your model should always be from a linearized graph, since we're trying to use slope intercept form. All right, let's review velocity versus time graphs. The same approach can be used to creating a velocity time graph. We're going to put velocity on the y-axis as the dependent variable. We're going to put the time on the x-axis as the independent variable. And it will tell us a couple of things. The velocity versus time graph helps us understand the displacement if we look at the area under the curve. And it also helps us figure out the acceleration if we look at the slope. Again, you're going to want to make sure that it is a linear relationship. And for your velocity time graph, even though your position time graph will be quadratic in nature for this example with the moving man, your velocity time graph actually should end up being linear. And so you won't have to linearize this one, and it's kind of given away in the rubric as well. But think about the fact that if you're going to put it in slope-intercept form, the y is your velocity, the slope is your acceleration, the x is time, and the y-intercept would be your initial velocity. So this would be this one on the left here, VF equals AT plus VO. That would be basically in slope-intercept form. Notice how that relates to the first kinematics equation we learned. All right, so keep that in mind, that relationship. All right, questions on velocity versus time graph? So here's the part that gets a bit tricky. I think getting your position time data won't be hard. You'll just set an acceleration to whatever you decide, and then get your data, and then make it into a table, and then graph it. And you can use Desmos, you can use TI Inspire software, you can use Excel, you can use Logger Pro, graphic analysis, whatever graphing program you want, you can use to make your graphs. I would suggest whatever you're most comfortable with and whatever your group agrees upon. Now, once you get that position time graph, it's not going to be linear, so you're going to have to linearize it. But what in the Moving Man lab, it shows you the position and time values, but I want you to, from the position time graph, determine the velocities. All right, and so remember, if we have a curved position time graph like this one, the way you can find instantaneous velocities, because you need to find instantaneous velocities, not average, is you either need to draw tangents or you need to draw secants. Now, someone unmute and remind us, what is the benefit of using a secant even though it doesn't give us instantaneous directly?
You can find the average velocity between 2 points that are really close. Oh, no, wait, no, you can find like the middle, right, the midpoint of the average velocity, and then find the slope of the instantaneous velocity.
Good. And the secant's much easier to find because to make a secant, you already have to pick 2 points. And a tangent, you only pick 1 point, and you have to make sure it's drawn precisely where it's only touching the curve at that 1 point, and the angles on both sides are exactly the same. Without a geometric construction process, it's hard to draw accurate tangents. Easy to draw secants, pick 2 points and draw a line with a ruler, right? That's pretty easy. And you won't necessarily even need to draw the secants as long as you have multiple position time points. Pick 2 points, use those 2 points to find the average slope. And like Jalen said, the average slope of that secant, or the slope of that secant, is the average velocity, but it would match the instantaneous velocity at the midpoint of that secant. So what you're going to be doing with your group is figuring out, okay, we've got all these points on our position time graph. If we pick these 2 points and find the average velocity for those 2 points, that would actually tell me the instantaneous at what position in time. Oh, it would be at the midpoint. So you're going to have to figure that out and make those connections. So you can, if you want, if you've got a way to make accurate tangents, you can use tangents, and the tangents will give you this, the slope of the tangent will be the instantaneous velocity at the point it touches. But unless you have an easy way to draw very precise tangents, secants are probably the better way to go, because you can just use the data points directly off your position time data table. Just remember, you need instantaneous velocity points. So if you're using secants, you're going to have to think about the slope of the secant line being instantaneous at the midpoint of that secant line, like we talked about in this section. All right, so flashbacks to a lot of different things that we've covered to help you process the lab today. Any questions about the review here before I walk you through the steps of the lab? All right, let me stop sharing this and go to Axis and show you kind of the rubric that's built in. All right, you guys seeing Axis okay? All right, if you go to assignments, this new lab I've just named Moving Man Lab number 2. All right, so Moving Man Lab number 2 is where you'll find it. If you click on Moving Man Lab number 2, you're going to see a big description. All right, so use the OneNote group created in Microsoft Teams, which you will find in the collaboration space on OneNote, and I'll walk you through all that process in case you haven't been using that in other classes. But you're going to put all of these things in OneNote. Okay, so you're not really going to be submitting it on Access this time. You're going to put it in OneNote. So you'll be creating data tables in OneNote. You'll be taking pictures or snapshots. And I would encourage you, don't take whole screenshots. If you take a whole screenshot, your graph may be a very small portion of that. And then it's much harder for me to see the detail on OneNote unless you trim it or crop it. But if you just use like a snipping tool, you can, and you can just, if you have a PC at least, I don't know about Macs, I'm sure they have something similar, but on a PC, if you just go down into the little type here to search, type snipping, it opens up a tool that's automatically installed on almost every PC. And then you can just exactly outline the graph that you've drawn and snip that in as an image. So you'll be putting your tables, you're putting your graphs, everything into OneNote. And in your groups, you will be working together to put it all into your same group page on OneNote. So I'll walk you through the whole OneNote and Teams thing here in a minute, but I want you to see the rubric. And this rubric is also in OneNote, but I wanted to show you here in Access. So you're going to collaborate to create the following in your OneNote. You need a position and time data table using the Moving Man. You're going to use that FET to generate data, follow the 8x10 rule, and here's a link. And so you can go back to the topics and find the link, but I also put it here for you. You might have to copy and paste it. So it doesn't look like it's a live link, a link in here. And then be sure to include your starting position, starting velocity, and acceleration values you selected. And you do need to make it you do need to give it an acceleration, like I said. You can't leave the acceleration at 0, make some value, and you can decide in your group what it will be. And then you're just gonna go like you did before, do playback, look at the position, look at the time as you're playing it back, and make a data table just like you did before. Last time you were following a little bit more specific directions. It said to set it at certain things. This time you get to kind of choose. You will probably still want to move the man all the way back to the other end. And you will want to decide, do we want to start him at 0 velocity just to make it easy? Or do you want to start him at some other velocity? That's what you'll have to decide in your group. And like I said, you need to give him some acceleration. Once you've collected the data and you see that it satisfies the 8x10 rule, then you're going to make a position time graph from it. Again, using Desmos, using Logger Pro, using TI Inspire, whatever software you want to use. And you can see that the position time table is worth 5 points and the position time graph is worth 5 points. It's pretty straightforward in those first 2 steps. And you've kind of already done those steps in the previous one, but just now with a new set of data. Then you need to linearize your position time data. And so you're going to need to create a table to do that. Remember the process we learned in Unit 1. You're going to adjust one of the variables by squaring it to make the relationship linear. And you're going to create a new table showing me what those squared values are. Okay, so you can either just copy and paste the other table and then change the one values, or you can make a completely new table. However you decide to do it, your group can decide. That's worth more points because that takes a little more effort. You're going to have to think about, how do we linearize it? What are we changing? What are we squaring? Do the calculations or have a spreadsheet do it for you. And then you're going to graph the linearized position time graph, and 10 points for that one too, because this is the first time we've done this. So you've drawn graphs before, but this is the first time you're going to linearize it and then take that data and then create a linearized graph in a lab setting. Okay. And then from that linearized graph, you're going to create the mathematical model in slope intercept form, but changing the y and the x and all that like we just reviewed. Now here's where it steps up even a little bit more. So that's mostly review. Okay, mostly review in those first 5 things. Then you're going to make a velocity time data table, but here's how you're going to do it. The Moving Man tells you the position and time, but it doesn't really tell you the velocities. So you're going to have to use the position time curved graph. You can't use the linearized one because in the linearized one, it won't be position and time anymore. It'll be something squared. One of them will be squared. You're going to have to figure that out with your group. So you need to use the curved position time graph, and you're going to need to use secants or tangents to find 5 instantaneous velocities at specific times. Okay, and you're going to show your work for that. So you don't necessarily have to draw the secants on, but you need to show the math that you're using to determine those midpoints. Because like Jalen said, if you use secants, you find the slope of that, but then you're also going to have to find the midpoint to know what time we're talking about for that instantaneous velocity. Once you've created that table with 5 points this time, so you don't have to have the full 8, you're just going to choose 5. You're going to graph velocity versus time with those 5 instantaneous velocities you use secants to determine. Then you're going to make a mathematical model, because this one will be linear. Okay, if you do it correctly, this one should be linear. So you won't have to do a linearization process. You'll just make a mathematical model in, again, slope-intercept form, but substituting all your variables. And then the next one is going to be brand new. This is the real challenge. So first part, mostly review. Second part, kind of review, but first time you've done the skills. This part, almost entirely new, using skills you've already learned, but in a completely new way. Now you're going to make a velocity versus position data table, and you're going to determine this data from above. I mean, you've got all this data up here, so you should know some velocities and you should be able to figure out positions. They need to be instantaneous velocities at certain positions. And notice I put velocity versus position. So velocity should be on the Y, position should be on the X. Follow the same pattern. Position versus time, position, time. Velocity versus time is velocity on the Y, time on the X. Velocity versus position, velocity on the Y, position on the X, all right? Now, when you graph velocity versus position, you're going to realize it's not linear. So then you're going to have to linearize that one, okay? And then you're going to make a mathematical model for it, right? And then in your conclusion, you're going to list the 3 mathematical models, the one for your linearized position time graph, the one for your already linear velocity time graph, and the one for your linearized velocity position graph. You're going to write them all down together, and you're going to write a few sentences making comparisons. How are they the same? How are they different? And how do they compare to the 3 kinematics equations that we learned? We technically learned 4, but I'm talking about the 3 that are on the College Board list. How do these mathematical models compare to those kinematics equations? All right. Questions about what you're expected to do before I show you a little bit about OneNote and Teams? All right. Let me stop sharing that and open up Teams. And you can go ahead and open up Teams now if you want, so you can kind of follow along. Logged me out, so. Oh, okay, try again. Okay, once you log into Teams, you probably won't have as many different teams to choose from as I do, unless a lot of your classes are using it. But you'll click on your AP Physics Section 1 team. And then up at the top, you should find a class notebook link. I'll give you a few seconds if you're trying to follow along and do this. Once you click on class notebook here at the top, you should, I think it probably opens up to this welcome to the class notebook page. That's what it does for me. If you click this little pointer over here, this little kind of arrowhead, it opens up a menu, and you won't see all the students here, I don't believe. I think you'll see content library, collaboration space, and then your own. I don't think you'll see anybody else's. I'm not sure. Maybe you see everybody. I don't know what it looks like on the student side. But you should at least find your own. And you should see a collaboration space for sure. Those 2 things are what you're going to need. Now I'm just going to open up Atticus's here. If you click on it, it's going to show you there's a notes tab and a lab tab and handouts and homework. And I haven't really been using this because everything's on Axis, But because of this lab, I did put in, if you click on the lab tab, you can see it automatically generates an untitled one, which you can delete if you want, but there's this moving man lab number 2. If you click on it, all that information that's on Axis is also right here. So you kind of got the rubric built in. So you can come to your lab page and review the rubric here, or you can look at it on Axis. It's in both places. But when you start working with your group, you're going to want to go to the collaboration space. Now, I'm not sure exactly, this is the first time I've used groups this way, so you guys are the guinea pigs. Did you guys get an invite, or do you only see one group in your collaboration space? How is it looking on student side? Someone unmute and tell me what's going on.
Sorry, go Finley.
Oh, I can only see one group.
Okay, so I assigned you all to different groups. So I thought that's probably the way it would work, but I wasn't sure. So when you go to that group, only the people that I've assigned to work with you should be there. And you should all be able to collaborate. You should all be able to add, edit, change. And what we'll do is I'm just going to allow you guys to decide, do you want me to set you up in a breakout room in Zoom? Or do you want to meet in Teams? In Teams, you can actually set up chats in Teams. So you guys can decide as a group how you want to do that. I'll put you in breakout rooms to start, so then you can decide if you want to stay in breakout room or if you want to use the chat room for Teams, or how you want to collaborate and cooperate to get this done. You'll probably want to do the beginning of it all together, going to the moving man, getting the data, setting up the table. And you'll want to probably do that part together. And then at that point, you can decide, do you want to divide up the work? Do you want to just keep working on it all together and doing it all together? How are you going to manage it once you get started? So that will be what you'll need to work with in your group to figure out how you're going to manage all that. I want to show you something here. So let me get out of, I don't want to do this in Atticus's. So let me go to my teacher one. So if you don't know how to make tables, I want to show you how you can do that. When you click on one of these scroll bars, it should allow you to kind of jump in to the OneNote page and start editing it. If you go to Insert, there's a nice table feature here. You'll have to click somewhere on the screen to be able to allow you to insert another one. So now I've got this little window, and then I can go to Insert. Oops, got to click it in there. Table. And then you can decide how big of a table do you want. Once you've created it, you can drag it anywhere you want. Okay, so you can move things around, you can paste in your labs and just drag things around. It's basically like a workspace, okay, that you can just manipulate and drag. And then in your table, you can say position, and then, oops, and start just making your table together. If you decide, oh, we don't want it that way, just highlight it and hit delete, it gets rid of it. All right, so it's fully editable. It's like a big work table to modify and edit together. All right, so that is how you use Teams. That is how you use OneNote. Questions?
So for the graphs and tables, our whole group has like one page with each graph and table, and then that's what you're gonna grade it off of.
Yeah, so I'll just be looking at your collaboration space. You don't need to submit anything to Axis. You'll just be putting everything in that collaboration space, and I'll just be going through the rubric and saying, do they have the position time table? Check. Is it correct? Okay, full points. Do they have the graph? Yep, looks good. Check. And you'll just be earning the points as the rubric lays out.
Because I have graphical analysis, could I just take a screenshot of the table and graph there and just copy and paste?
Sure.
Okay.
Yeah, so that's the thing, that in your groups you'll decide, what software do you want to use, who's really good at it, and divide up the work how you want, talk it through, and coordinate that way. Yeah, so you can use whatever software features you want to create those graphs and tables. You don't have to do it the way I showed you. I was just giving you, a lot of students don't realize you can make tables right in OneNote, so just showing you that as an option. Other questions? Hello, international students, those of you that are learning remotely. So we've got David and Greg in period 1, Lexi in period 3, Jack and Robin in period 4, and Selena and Jackie in period 5. You obviously won't be able to work synchronously with the class. And so I didn't put you into groups for this project. You can work as groups. You can decide if you want to try to coordinate. So again, it's David, Greg, Lexi, Jack, Robin, Selena, and Jackie. If you'd like to coordinate with each other and create some groups, you may. If you'd rather just work on your own, if it's too hard to coordinate to get together, that's fine. But because they're working at this time of the day during class, and that's going to be difficult for you, I'm giving you more flexibility in whether you would like to do it as an individual or whether you would like to coordinate yourself with one of those other international students and do it as a partnership. Either way, I'm also going to give you some flexibility on whether you would like to submit everything on OneNote or whether you would like to submit everything in another way through email or through Access. So you guys have a little bit more flexibility, whether you want to work individually, whether you want to work in a group, whether you want to submit it in OneNote, whether you want to submit it in Access or by email, but you'll still have to do the same requirements. So hopefully you've watched the earlier part of this video where I've given the description and given the explanations, and you can go back, watch it again if you need to. You can read through the description on Access. You can read through the description on OneNote, whether you decide to put your answers there or not. And then if you have any questions, let me know. Quite a few of you tend to write me through Access in the messaging system, and that's okay. But unless I'm online, I won't necessarily know that you've done that. So if you need a quicker response, email is generally a little bit better. So you can just email wweb@oakschristian.org. If you do send something through Access in the messaging system, I will eventually see it. It probably just won't happen quite as quick unless I happen to be online when you send it. I happen to be on Access when you send it. All right, so I hope that makes sense. Let me know if you have any questions. A little bit of flexibility on how you're going to turn it in, but you still have to turn in the same work with all the same graphs and tables and linearizations and models and conclusion. So make sure you read that rubric carefully in the description. Hope that helps. Thanks.